You have get 15 minutes to talk your words or present your paper, and then 5 minutes for questionnaire session for answering the question from the participant. So I think I'm quite strict about this. So before finishing your presentation, about 1 minute before, I warning you, and then going to stop you when is 20 minutes is up. Okay, so I thank you again to everyone, and I'd like to get started now, and that's so first presenter. I'd like to invite Sohag Chandra Das to present your paper. Thank you.
কানেকশন কি সমস্যা নাকি স্যার? লাইনে সমস্যা? এখন আসছে লাইনে সমস্যা, আবার চলে গেছে। চেঞ্জ করবো এটা দিয়ে। Good afternoon to all and greetings. I'm Sohag Chandra Das. The topic I will be presenting today is entitled Comparative Study of UV Protective Dyes from Terminalia arjuna and Punica granatum, Modern Techniques and Sustainability in Textile Production. So the study is not finished yet, and we are presenting a bit part of the work. So we did not reach the conclusion yet. And this is from undergraduate students. So this is the outline of the study, and I'll be talking about introduction, objectives, materials, method, resultant discussion, and obviously conclusion. So the world is increasingly worried about the synthetic dyes and chemicals because of their detrimental impacts to our environment as well as health. For this reason, we are using natural dyes which are eco-friendly and which contains some of inherent limitations like lack of substantiveness, color fastness. So to solve this problem or to address this problem, we are using mordants which is used to form the bind between dyes and fiber, and specifically biomordants which are used for their eco-friendly and non-toxic characteristics. Punica granatum, which is actually known as pomegranate, and the peel of pomegranate contains tannin. So we know that tannin is a type of mordantic agent and which has unique capability which is UV resistant and which can protect us from UV ray. And these chemicals contains two specific components. One is granatonin and another is elazatannin, which are actually type of tannin and which contribute in the antimicrobial and UV protection properties. So from the introduction, we can infer our objective of the study, and the objectives are extracting dye from the terminal arjuna, extracting mordant from the peel of Punica granatum, examining color fastness, visual appeal of the fabrics, investigating UVB's properties, and identifying functional groups. Finally, there are few studies that should be taken, sustainability, highlighting the environmental impacts. So here are the materials we have used. As dye, we used T. Arjuna, which has been collected from Dhamra Upazila, and these were powdered with the help of grinder. And as in case of mordant, we used pomegranate skill and used grinder mortar pestle. And all of the samples were stored in the container for further use. So let's go to the method section. So dye was extraction, and as well as biomordant was extracted both in aqueous solution. We used 1:20 mstl ratio for the powder bark, and the temperature was 60 to 70 degrees Celsius for 45 minutes. And then these were filtered with the help of filtration medium, and the pH was about 5.5 after the filtration when it was cooled, and after those the samples were stored in the airtight container. In case of biomordant, we also used the similar procedure in the aqueous solution. The mstl was 1:10 and pH was 4.5 and temperature was 70 degrees Celsius for 45 minutes. And similarly, it was actually filtered and kept in the airtight container. Now let's go to the preparation of the cotton fabric. We know that the preparation needs pre-treatment. So here we used single jersey cotton fabric, white cotton fabric actually, and we used salt, detergent for 70 degrees Celsius for 25 minutes, and we removed the impurities, starch, other kinds of wax materials. And finally, thoroughly washed the hot water, and lastly washed with normal water and rinsed and air dried. Now let's go to our final and actual main section. This is mordanting and dyeing. So we actually followed 3 steps. One is without mordant, dyeing without mordant, and another is dyeing with biomordant, and last one is dyeing with commercial alum, which is metal mordant. So let's go to the dyeing with without mordant. So without mordant is the actual normal process. We used mstl 1:20, and we went for both acidic and basic pH. Actually, 2 samples was tried for acidic and basic, which was 10.5 and as well as 5.5, and the temperature was ranging from 60 to 70 degrees Celsius for 1 hour. After that, we rinsed the sample, squeezed it, air dried it, and ended the drying process. Now let's go to the biomordanting and dyeing. So dyeing with biomordant has 3 steps. One is pre-biomordant, one is meta-mordant, and as post-mordant. So pre-mordanting is contains the mordanting before the dyeing. So we used 1:10 mstl for pH 4.5 for 60 to 70 degrees Celsius for 40 minutes. After the mordanting, then we used dyeing, and both acidic and alkali condition for 60 to 70 degrees Celsius for 1 hour. And for meta-mordanting, the process was done simultaneously. So actually the mordant and dyes was used simultaneously. There also the mstl was 1:20, pH were also same. Specifically, the dye was used 5% and mordant was used 10%. And for post-mordanting process, mstl was 1:20 and pH was same and 60 to 70 degrees Celsius for 1 hour. This was dyeing. After dyeing, then we used mordanting, and mordanting was done at pH 4.5, 60 to 70 degrees Celsius for 40 minutes. Now let's go to our final mordanting, which was done with metal mordant and commercially available as alum. It was conducted at 2% on the weight of fabric, 2% of the weight of the alum, 70 degrees Celsius and 40 minutes. And then dyeing was conducted similarly in both acidic and basic condition. Finally, we used rinsing, pressing, final air drying, and end of drying process. So these are actually our methods. Now let's go to some analysis. We used FTR analysis for functional group changing or comparison. We used Parkin-Elmer for UV exhaustion for detecting exhaustion percentage as well as absorbency. We also used Parkin-Elmer UV bis lambda 365. We also tested the color fastness to wash and color fastness to rubbing. Let's go to the resultant discussion section. Firstly, let's see what has happened in the physical appearance of the mordanted and dyed fabric. If you see in the left figures, we can see without mordant, pre-biomordant, meta-biomordanted fabric. So it can easily visible that the pre-biomordanted fabric showed the better color than the other ones. And in the next in the next slide, we can also see that if we compare similarly post-biomodern with alum-modernted, so it can be easily detect that the alum-modernted fabric showed better than this post-biomodernted. However, the previous one, the pre-biomodernted fabric showed the better one, and this is for this is the comparison between pre-biomodernted and alum-modernted. So we can conclude that the pre-biomodernted fabric showed a comparable comparison between the existing market modern. Now let's go to color fastest to wash. You will see that color fastest to wash. Similarly here, the color fastness to wash of pre-biomodernted fabric and alum-modernted fabric also show comparison, comparative relative fastest properties. However, there is a little, we can say that without modern, here there is the color fastness was better than other ones. We can say here that if you don't have anything, you have nothing to lose. Similarly here, the fastness is better, but it doesn't mean it's doing the great dyeing properties. And if we see the rubbing properties, we can see that in all cases, like the pre-biomodernted, meta-biomodernted, and post-biomodernted, three showed better dry and wet rubbing properties comparing to alum-modernted fabric. And now let's go to UVB spectrum. In the left figure, we can see that T. Arjun and the combination of T. Arjun and P. Granatum showed the absorbency, UVB's absorbency in 277 nanometer, so which falls into UVB region. Similarly, the only P. Granatum showed the absorbency in 273 nanometer, which is actually UVC region. So we can say that these dyes as well as this modern can absorb the UV light. In the FTR analysis, we can see that the dyed fabric and modernted fabric showed comparable functional groups with the other kinds of tannin-based components. So in conclusion, we can say that the study underscored the efficiency of Terminella arjuna and Paeonica granatum as a source of natural dye as well as a biomodern for sustainable alternative of synthetic chemical in textile industry Bangladesh. And these also exhibit notable UVB protective properties. Also shows satisfactory color fastness, visual appeal of cotton textile treated fabric. However, this research is not fully completed. It is so you can say 30% has been completed. The rest will be completed in next. So this work is actually could focus on optimizing the dyeing modernity process using Terminella arjuna, Paeonica granatum for further use for UV protection, explore the antimicrobial or eco-friendly properties. Thank you.
Thank you, Shohag. You have completed within the time frame. Be ready for questionnaire session. Do you have any questions?
Okay, thank you very much, Mr. Shohag Chandra Das. So my observation is you mentioned the UV protective dyes, right?
Yes,
UV
sir.
protective.
Yes, sir.
Can you show us any results like UV protective?
Well, sir, I said we have not finished the project yet, but we can say that when the thing absorb the region of UV region, so we can say that it is UV absorbing component. So if we use it on the surface of fabric, it can easily absorb the UV light because it's showing that 2277 nanometer is in the range of UVB and 2073 nanometer is the region of UVC. So if we apply it on the surface of the fabric, when the sunlight comes, it can absorb that region's wavelength. So we can.
It's actually the dye stuff you say. The Terminella arjuna has UV protective, but when you use in the surface of the fabric, it may not activate like UV protective agent or UV protection. So I think you need to check it. And another thing is that pre-mordanting, you use that 1 to 10%, right? For pre-mordanting, you use 1 to 10% material liquor ratio, 1:10, 1:10. But in case of the mordanting and post-mordanting, you use 1:20. That's why the pre-mordanting result is better than the post-mordanting. So why you change the material liquor ratio?
Actually, sir, there has been very different things we did not explain here because when we did the pre-mordanting process, there was no dye stuff. Thus, there was only the fabric. But in case of meta-modern tinting and post-modern tinting, we used in post-modern tinting we actually used the dye stuff first, then the modern tinting process. If we, I have cited the papers in the reference, and we could not show it here, but in the references we followed the reference, and it showed that the if we use dye stuff and other kinds of things, it can increase the amistrial ratio. That's why we used it.
Okay, okay, thank you.
Thank you so much for your nice presentation. If I consider myself as a customer or buyer, I will not care about which sources you have collected the dyes. So I will think about the costing and also the fabric quality. So do you think that as compared to the conventional vegetable dyes or something like that, in which way you are something behind, you are faster, your research is better than the conventional one? And because whenever you do any research, you must have some background that like this, we are facing problem regarding the UV protection factor, natural dyes, this cannot meet our requirement. So this can be beneficial for the textile sector like this. So my question is, there are so many dyes, so many natural dyes. So why you have again research about this topic?
I think you are talking about Bangladesh, but we are not talking about Bangladesh. We are trying to export it outside. So if we want to export it outside, we need to convince them. Like in my country, we think our labor does not have any value, but outside the labor has so much values. If a labor works in 100 floor building, they need protection from sunlight, right? So if we want to protect them, we need to increase the price of the product, and they will of course buy it if we can convince them. And you can say that already there are lots of dyes in our market which are synthetic. But you know that sustainability means we are actually trying to deny the synthetic dyes. So that's why we need to go for natural. And for sustainability, I think natural is the best solution.
Can you compare like this? In the market there are vegetable dyes, maybe no UV protection dyes. So they use vegetable dyes with additional UV protection chemical. So if you compare with the conventional one and with your innovation one, how will be benefited?
Actually, if we add the extra chemical, then that means it's synthetic, it's not natural. And this has already imposed the chemical which is tannin, and tannin presents huge amount in this chemical. There are lots of studies regarding this. We are just applying this chemical and this tannin in the fabric. So I think this is a solution, because if you add the chemicals with the natural dyes, that would not be sustainability.
And do you have any would you use this chemical in the exhaust process or the garment washing?
Sorry, I could not catch your question.
In Bangladesh there are two ways, maybe the exhaust dyeing process, neat dyeing, mostly exhaust process, and another is garment washing. So the scope, if you think about the scope of application of your dyes, where you will use your dyes? In the exhaust or washing?
We are already using some natural dyes in the industry. We will apply the similar process.
Which sector, exhaust or washing?
No, we are not actually known about this thing, because we are not going for the bulk production. We are doing in laboratory. So in laboratory, we are doing in laboratory dyeing machine in the pot. So I think we will think about that in next of the study, because if we success, then we will go for that. How do we dye this fabric in the industry for bulk production? But we are not thinking about this now.
You have to think, because you
yes, I will think.
For your kind information, nowadays no natural dyes can be used in the exhaust process. Only the washing
yeah,
washing
that's thank you for the suggestion.
And another thing was that the fabric gauge, the machine gauge of the knitting machine, if you have used the knit fabrics, gauge plays a big role. So in your experiment, what was the gauge of the fabric?
No, I did not say about that. Basically, we use the one fabric. We did not vary the gauge or GSM of the fabric. I said that if we can be successful of the study, then we'll go for different variation of the study. Like say, we'll go for 150 GSM, 250 GSM, 200
Not only
GSM.
GSM, not only GSM. You have to think it first, because if you use maybe the 18 gauge fabric, if you use 24 gauge, your 18 gauge fabric will not pass. Although your dyes has UV protection, yeah. So you have to think first also. Maybe your very tight fabric, UV protection fabric works only with very tighter fabrics, not the loose one. So you have to think also this one. Otherwise, your research will be failed.
Yeah, thanks for your suggestion. We will take suggestion from you or other kinds of expert if you success in the study.
Yeah, thank you so much.
Thank you. Thank you very much. I think it's over. No more question.
No more
It's
question.
over. Time is over. We
No
have
more
to move on next presenter. So I like to invite Nusrat Jahan to present his paper.
Assalamu alaikum. Good evening. Thank you very much for welcoming me here, this conference. I am welcoming all of you for my presentation. My presentation topic is analysis of mosquito repellency of viscose and cotton model blend fabric dyed with Ocimum basilicum plant extract by CPB method. Here I am the presenter and corresponding author of this research article, and I am working in a university, that is Northern University Bangladesh, and also working as a judge of social business creation, HEC Montreal, Canada. In my research paper, here is another 4 co-authors who are not present today here, but they are helping so much to overcome this research. So let's begin to our presentation. My presentation content is, first of all, I will discuss about abstract, then objectives, background of the research, material method, result and discussion, then limitation or research gap, then conclusion, and last of all, references. Basically, in this my research paper, I intended to evaluate mosquito repellency property of dyed viscose and cotton model blend fabric with the plant extract of Ocimum basilicum leaves, and my main target is to treated these 2 samples by CPB method, that means cold pad batch method. We all know that Ocimum basilicum plant is a source of medical and traditional Ayurvedic medicine. That's why I choose this chemical for treated my sample. The main objectives of my research is to extract the dye liquor from Ocimum basilicum leaves. Then I determined the absorbance or optical density of this dye extract by UV spectrophotometer. Then characterize the dyed sample by color strength and different color fastness parameter. And then my main research to target is to evaluate the mosquito repellency property by WHO Caucase method, and also evaluate the allergic reaction of this dyed sample. The background of my research. There are many research work that focus on natural dyeing with cotton and especially silk fabric, but there are no focus on dyeing performance with functional finish like antimicrobial or mosquito repellency, this type of finish with this plant extract, and especially cold pad batch method. So as there are no researcher focus on these 2 fabrics, especially viscose and cotton model blend fabric, that's why I choose these 2 fabrics for these functional finishes. The substrate I choose that is collected from Alliance Neat Composite Limited, that is situated from Jirabo, Shabhar, and my two sample that is viscose, and this viscose is a rib, 4x rib weave, and the cotton model blend sample is a single jersey that has 250 GSM. Before treating my sample, I have to extract the liquor from the Osimum basilicum plant extract. For that reason, I have collected the leaves, then washed and cleaned the leaves and dried by sunlight for 48 hours for removing all moisture from the leaves, and then powdered and then measured the powdered materials. After measuring the powder materials, I maintain 1:5 extraction ratio, that is 90 gram of powdered material and 450 ml methanol. Methanol is my extraction solvent. After preparing my all measurement, then I sealed the conical flax and take the material into a shaker for 48 hours, that is 8 hours per day. As we all know, factory are not open 24 hours, so that's why I took 5 days for extracting this dye material. After extracting the dye solution, I heated the solution for evaluating all the methanol from the dye solution, and then I got the sample, and that's I measured the pH, that is 5.6. And it's we can say it's more acidic or neutral solution. The recipe that I maintained in CPB method, there actually is some pickup percentage maintaining CPB method, and I take 70% pickup, and the product pressure was 1.2 megapascal, and I maintaining 1:10 liquor ratio for dyeing. And I padded 5 times to treat the sample. Characterizing method. I did optical density or absorbance of dye extract, then color strength or color fastness, then mosquito repellency and allergic test. Case method. We all know about how mosquitoes are painful in our daily life. That's a small tribute for me and my 4 co-author, that how we can minimize this problem using fabric. This is the main reason we took this research, and WHO standard method we follow, but maximum researchers followed modified case method, so that's why we also followed the modified case method, and for that reason we made a case that has 20 centimeter length, 18 centimeter width and 30 centimeter height, and we also prepared by a paper board and plastic material. Paper board is used for shaping the material, and plastic is used to cover up the whole case. And we also give a 3 cm opening for insertion of fabric and also insertion the mosquitoes. We collect the mosquitoes near a fish market, so the generation or the species of mosquitoes cannot be determined for my in this my research. And we took a 3x3 inch size samples for this test method. Here is the widely used mosquito repellency test formula, that is U minus T divided by U. That is, T is the number of mosquitoes seated on treated sample, and U is the number of mosquitoes seated on the untreated sample. An allergic test method. For testing the allergic test method, here we choose a person skin. As a small person skin is a small person, by wrapping that fabric, and after wrapping the fabric we observe for 8 hours. Then if there is any rashes, then we can say the fabric has any allergic reaction or not have any allergic reaction. Now the main and most promising part of is laser and discussion. First of all, the optical density or absorbance of dye extract. We use UV spectrophotometer in Weinstein laboratory. There I get this absorbance data, and we measure against a wavelength that is 200 to 700 nanometer. And by this optical density, we got the highest absorbance peak at 270 nanometer, 320 nanometer, and 380 nanometer. That is 3.74, 3.92, and 3.31 respectively. And in that region, we get the highest absorbance peak, and this is the value of that peak that is shown in the figure. And it's claimed that the main dye strength is remained in 270 to 320 and 380 nanometer. The visual appearance, as you all see that it's an electronic scan, so here is a little bit difference from original sample. All the sample is as the leaves are near to close to green, so all the sample color yield is light green, and we measure it from Pantone shade, and the viscose sample give the Pantone shade of 18032 for TCX, that name is Calistic Green, and also cotton model sample gave the Pantone shade 170525 TCX named Monstone. And here I'm forgetting to mention that I renamed the dyed viscose sample by V1 and cotton model sample CM1. Color strength. We all know about the colorimetric analysis, and for colorimetric analysis, here is LAB value, but I am not presenting the LAB value here. For the colorimetric analysis, I only represent here color strength value, and in terms of K by S value, we all know the Kubelka-Manek theory, and this K by S value is termed by Kubelka-Manek theory, and here I got the K by S value of viscose sample is 11.02 at 270 nanometer, and 9.76 at 250 nanometer got for cotton model sample. And the main part is mosquito repellence properties. When we did the test, we got that the viscose sample displayed averagely 50% of mosquito repellency, whereas cotton model sample showed mosquito repellency but not good. It averagely showed 32.5% mosquito repellency. So it can be established that the treated viscose fabric with Ocimum basilicum plant extract has better repellency activity compared to cotton model blend fabric. Allergic properties, as it's a natural ingredient, so we got no rashes or blistering in human skin, so we can conclude that this plant has or fabric has no allergic reaction on human skin. And the color fastness properties, we did color fastness to rubbing, perspiration, water, wash, light, etc. And we see that all of the result for viscose sample gave the better color fastness result than cotton model sample. In case of wet rubbing and dry rubbing, viscose sample give 4/5 and 4 rating, where cotton model sample give 3/4 and 4 ratings. And in case of color fastness to water, in ultimate color change, we see that it displayed 4 rating of viscose sample and 3/4 rating of color fastness of cotton model sample. All the multi-fiber staining, viscose sample have 4 rating, but the cotton model sample have only 2 sample, that is nylon and polyester, have 4, and others are 3/4 ratings. In case of color fastness to wash,
sorry, I'm going to interrupt you. You have already
I exceeded.
finished.
Okay, okay, I'm just.
Within 1 minute, you have to finish.
Okay. For color fastest to light, we got the very good result of both sample, that is 4. And the research gap or limitation, it's basically the permanency of treated sample as the functional finishing is achieved by natural ingredient. So here is the challenges to take the durability of these washes for multiple washes. So it can be limitation or it can be a further research area or investigation. So if I conclude the whole thesis, we can say that this plant can be important or functional finishes ingredients. We can use this plant for mosquito repellency, antimicrobial, and other different type of functional finishes. And here we say that viscose sample gave better mosquito repellency rather than cotton model sample. So if we can commercialize this fabric, we must take some certain researches, and then we can commercialize this mosquito repellency fabric for our consumer. There is some references that I took for this research. Thank you. If you have any question, please.
Assalamu alaikum. Thank you so much for your nice presentation. So actually, you have used tulsi, right?
Yes, yes.
Tulsi. Okay. So you use the scientific name. So we know that tulsi is a medicinal herb, or widely used in antimicrobial finishing. You claim that the treated fabric that you treat with the tulsi extract will be anti-mosquito, or that means here have a mechanism to deactivate the mosquito or others. So what is the mechanism behind this? How you prove your treated sample will be anti-mosquito?
Here is, as is we all know, it's a traditional or Ayurvedic chemical. So here is the antimicrobial properties in itself, and it is established before. But here is no research that is claimed that it has the mosquito repellency. As it's it has the antimicrobial. So when I tested WHO standard, we got that mosquitoes are not seated on the treated sample. So that's why we can say that it has the mosquito repellency properties.
So we know that it's antimicrobial or antibacterial properties, and mosquito repellent actually
yes, it
not
has,
same.
It has antimicrobial properties, and I have another paper where I mentioned that it has antimicrobial properties, and that I'm tested. But here is a simple one type of portion I mentioned that has a mosquito repellency properties.
As I understand, that key focus was the anti-mosquito. And
yes.
The key focus of your research was the
Yes.
anti-mosquito. So it is not the same, the antibacterial and anti-mosquito. And the mechanism or any scientific scholarly article behind the deactivate the mosquito. So I think further study is needed here.
As I did not take any SEM test, if I did that test, then I will differentiate the before sample and after sample. So
but SEM indicates the morphological structure,
yes, it's
not
morphological structure.
the
Okay, thank you.
so, thank you so much for your
It's a
presentation.
simple research article.
Give other persons to opportunity to ask a question. Do you have any question, others?
Just very basic question. Why have you used one sample viscose and another cotton modal? Why not cotton viscose? You have
Okay.
used two samples. One is viscose,
Yes.
ribs, 4x3, 4x2, and another is cotton modal. My question is, one is viscose, another cotton modal. Why is not cotton viscose?
Okay, okay. As I mentioned, that many researchers worked on cotton and silk sample for mosquito repellency. That means cotton has mosquito repellent properties for any kind of herbal medicine, but there is no research that used viscose or model sample. We know model is one kind of rayon sample. So that's why I took model sample, cotton model sample and viscose. For it's just 2 samples.
I understand.
I just took 2 samples.
Maybe
and it also and these 2 samples has the medical value also and own healing process also.
I understand.
That's why I took these 2 samples.
One is viscose,
Yes.
another is cotton modal. My
Yes.
question is, why not cotton viscose? So maybe the simple question.
I am a researcher and I think that it would be more convenient for me. That's why I took those samples.
I think the real reply is, I have found this sample available. It was available, maybe.
Yes, also it was available. But if I search cotton viscose sample, that was also available in the market.
Next, very quick question. Why CPB method you have used instead of
Because
exhaust?
in exhaust method, all my treated sample, the treated chemicals will be washed off. That's why I choose CPB method.
I don't think so. This is the real answer. And your data is very discrepancy here. I have found that you have used 30 count, but your GSM is 250.
Yes.
With the stitch length is 3.06 millimeter. It couldn't be. It cannot be at all. Single jersey fabric, 50% cotton, 50% modal. Your yarn count was 30, and the GSM is 250. Why? How?
Where I got the sample, they mentioned that
Now, do you
there
think
is
that using 30 count, the fabric GSM would be 250? Okay,
Okay,
thank you,
sir,
thank you.
it's a reap. That's why I
Thank
think.
you. Okay, thank you. We have tried to question 1 because we have a limited time, only 5 minutes. So I have to give chance to other persons also.
Thank you for your nice presentation. And my question is that you have used human skin. So my query is that can we use direct human skin? Even though we know this tulsi, but what you have used, it's a herbal.
Yes.
But according to medical science, we cannot use directly human skin. It could be a life-threatening also. So have you followed any procedure that before applying these dyes to human skin to measure the allergy?
No, ma'am. Only treated fabric sample.
So you have to do that. Okay. Thank you.
Thank you.
Do you have more question? Okay. Give him. Oh, chole gelo. You have a question?
You have 5% shade, and you have also mentioned about you have used 70% pickup, right?
Yes.
Okay. So 5% shade and 70%.
Not 5% shade.
So you have mentioned there. So shade percent is 5%.
Yes,
What does it
extraction
mean?
percentage. That means dyes amount.
This is
5 gram per day.
Is this solution?
Yes, it's a
So
solution.
It's not shade
Is this
percentage,
called
right?
the shade percentage?
No, it's not.
So
No, it's
shade
not the
percentage.
correct
So-
information. yeah?
Right.
Yeah.
So this
Yes.
is not shade percentage. And another one is, I will ask you that pickup percentage is 70.
70.
Only 1 pickup percentage.
Yes.
And so isn't it difficult to conclude it has anti-mosquito properties with only 70 or only 1 pickup percentage? If you could use 70%, 80%, 90%, and respectively, if the anti-mosquito properties will increase, then will it be better to conclude
Yes,
this?
of course. If I did more pickup percentage, then I will get more performance.
You haven't shown it.
No,
so how
I'm
could
not-
you tell this
I'm
about
just
this?
did a simple test here.
So thank you.
Okay.
Thank you, Nustrat. So we move on the next one. Sumi Tabassum Ushno. I invite you. Ushno.
Assalamu alaikum. I am Suimita Basu Mushno. I am from Bangladesh University of Textiles, 44th batch. Today, my title of my work is Formulation of Nature-Based Softeners and Compare Performance with Commercial Softeners for Textile Application. I am the main author of this work, and my co-authors are Ashish Kormokar, MD Asadullah, Farhad Hussain Farooq, Tanvir Ahmed, and our Honorable MD Muhammad Abbasuddin Shaikh sir is the corresponding author of this work. Thank you for giving me the floor for presenting my work. So these are my contents. Today I will be discussing about the introduction, objectives, materials and methods, results, discussion, and the conclusion. Let's move on to the introductory part. Today, I will be discussing about our formulated softener, which is totally nature-based. That means the raw materials were natural products like aloe vera, coconut oil, and okra. And after that, we have compared it with the commercially available softeners that are in the market and are randomly using in the industries. We all know softeners are very crucial product in our textile industry, which improves the tactile qualities of fabric, like the softness, comforts, and also it improves the flexibility and the drape of the fabric. It plays a very significant role in the textile processes. So these are our objectives. So when we first started with our work, our aim was to formulate an eco-friendly softener which will be totally nature-based, and after that comparing it with other commercial softeners which have been using in the industries to find out an alternative product of commercial synthetic softeners. These are the materials that we have used in our work. Firstly, we used aloe vera, as aloe vera is very much locally available and it also contains a few amount of fatty acid, which is linoleic acid. So that's why we have chosen aloe vera as our first raw material. We used aloe vera extract, that means the gel of aloe vera, and we used it 40% in amount, and the rest of the amount was water, and no chemicals was used in this experiment. And then we moved on with okra. As we all know, okra gives a slippery effect. That's why we chose okra for our second product. And here we also used the same percentage of raw material and water. Then we used coconut oil. As softeners contains fatty acid, fatty acid basically does the work of softening, so that we chose coconut oil as it has a huge amount of saturated fat. Basically this is lauric acid, also stearic acid, oleic acid. And coconut oil is also very much available in our local market, and it's also cheap. So that's why we chose coconut oil for our third raw material, and we use 30% of coconut oil. For making an oil in water emulsion, we need emulsifier, and we use also a natural emulsifier, which is egg yolk, a source of lecithin. We used a bit amount of fragrance, and rest of the amount was water. So these are our recipes of our work. Then we applied the formulated softener in 100% cotton fabric, knitted cotton fabric. and we used both padding and exhaustion method. In padding method, softener concentration was 20 to 25 gram per liter. We kept the pH between 4 to 5, and here the pickup percentage was 70 to 80%. After that, we did some performance analysis. So we used 4 criteria to evaluate our formulated softeners. At first, we used test panel scoring. Then we measured the bending length in STM D1388 method. Also, we measured the crease recovery by ATC 662008, and we used Charlie crease recovery test. After that, we used water absorbency test in ATCC 792014. It was mainly a drop test. And these are our results of the of our softeners. We basically compared our softener with the commercially available softeners, and these are the results. Firstly, it was test panel scoring, in which 5 panelists were chosen, and they assessed the treated fabric on a 5-point scale ranging from 1 to 5. And here, score 1 means the least soft, and the score 5 means the most soft. Each evaluation were total and average to determine a single rating for each treated product. For the aloe vera treated fabric, the score was 2, and for the okra treated fabric, the score was 1, and for coconut oil softener treated fabric, the score was 4. That means the coconut oil softener got the best score from the panelists, so it was the most soft from all of them. After that, we measured the bending length of our samples. Here, the untreated fabric scored 1.95 centimeter of bending length. In recipe A, that means the aloe vera got 1.92 centimeter of bending length. In okra softener, it was 2.07, and in our coconut oil softener treated fabric, it was 1.35. So we can see that the lowest bending length was for coconut oil softener treated fabric. And we all know the lower the bending length is, the higher the drape and the flexibility. So here also the coconut oil softener treated fabric performed the best. And for aloe vera treated fabric and the okra treated fabric, the score was not that good, so it showed not that much good flexibility and drape. Then we tested crease recovery. Here we tested the crease recovery angle. We can see that the untreated fabric was 16 degree, and aloe vera treated fabric was 84 degree. Okra treated fabric was 56, and coconut oil softener treated fabric got 74 degree. So in this test, the aloe vera treated fabric scored the best, and it showed the highest crease recovery angle. That means it has the most ability to rebound after creasing. And here, after that, comes the coconut oil softener treated fabric, which slightly performed less than that of aloe vera treated fabric. In this case, also the okra treated fabric performed not well. Then we performed water absorbency test, which depicts the water retaining ability of any sample. We tested it in drop test method, and in untreated fabric, the sink time was less than 1, also in okra treated fabric. And for coconut oil softener treated fabric, the sink time was very high, 5.19. So it proves that it has the ability to retain water most, and it also is a proof of its softness. Then we compared the commercially available softener, which we collected from Pakija Neat Composite, which is situated in Savar. It was a cationic softener, and here are the test results. In hand-fill test, our coconut oil softener got 4, whereas the commercial softener got 5 from the panelists. And water absorbency test, our coconut oil softener 5.19 seconds it took to sink the droplet, and the commercial one performed a bit good, better than the coconut oil softener, but the results are quite comparable, I think. And in crease recovery test, the crease recovery angle of commercial softener is 85 degree, whereas in coconut oil softener treated fabric it was 74 degree. So in this case, the results are also comparable. Bending angle was 1.15 for commercial softener, and for coconut oil softener it was 1.35. We basically tested our best perform softener, which is coconut oil softener, with the commercially available ones. We didn't compare the aloe vera and the okra treated fabric because they didn't perform up to the mark. So we just compared a coconut oil softener with the commercially available softeners. And the motto of this comparison was to find out an alternative nature-friendly solution of synthetic commercially available softeners, and we got some observations.
Sorry, I'm going to interrupt you. His time is over. You stop there, I think. I'm going to the participant question or else. Do you have any questions? Please. Try to ask one question for each.
Thank you for your presentation. So, could you explain about the chemical structure of the bio-based softener you mentioned?
Basically, it contains, in coconut oil softener, it is basically lauric acid. So this lauric acid have positive and negative part, and it can do the work of softening. As we know, for softening we need hydrophobic and hydrophilic part, and also a positive and negative part. So it will do the work of softening.
So you think it's a softener? How can you say?
Sir, it did the work of softening actually, and we have tested with 4 criteria.
You have to check, I think. As a softener, there are some, some categories, there are some point. So you have to, there are several methods, ISO, ICTSE. So then you can compare with them, and you can mention this, you can tell this is the softening agent. Otherwise, I think it's not a softener. It's just a, it's called, slippery lubricating agent.
We mentioned in our 4 criteria ICTSE methods.
Hydrolyze it, you get glycerin and chlorate. Not free fatty acid.
Very interesting research of yourself. I'm very much surprising that your research is against humanity, because you are using the food which is supposed to be consumed by the people, not the fabric. And whereas it is very expensive to consume one coconut and very costly. So and also you use egg yolk. So very much costly. I don't know who will use it, although if it is commercially feasible. Number 2 is it could be very bad smell. with the egg yolk and also the coconut oil. Have you tested the smell also?
Sir, in our limitation sections, we mentioned that if we can use a better emulsifier, it could be better. It was our limitation.
Have you tested the smell test?
Also, there is a fragrance of coconut oil. So the smell was not that bad, as far as I know, as far as I smelled. And sir, we also use coconut oil for our hair. So
yeah, it is very expensive, and also okra. People cannot buy it. It is very expensive. So I think research should not supposed to be used the food which supposed to be consumed by the mankind. Thank you.
I have a question here. How many samples you have tested for each cases?
For each cases, we have tried almost 20 to 25.
Is followed by the standard?
Yes.
No, I think you.
We have been doing this for long, so we got enough time before.
What is your average value? You show only the average value. You have to put the each value also.
Actually, we at first set a standard, and then
I have already seen that you follow the standard, but all the procedures you have to follow. No, I think
we tried them in under different conditions.
You have to mention also that way.
We presented the best.
Do you have any other question, please? Yes.
You didn't mention the methodology. Why? In your slide, how did you work this? Like this aloe vera and coconut oil applied. How did you apply there on the fabric? I think it should be very difficult to apply any kind of oils on the fabric smoothly and evenly.
It is in our paper actually.
But you have to present this. And my first query was also that your presentation title and your paper published in the proceedings is it's different. Your title and that PPT and in the proceedings, it's different. So why it is different?
The title is different.
Yes. So during presentation, you have to careful about it. Okay?
Okay.
So, anyone? Do you have any question? So I have to stop here. So thank you.
Thank you.
So next one, I invite Mohibul Hassan Choudhury to present your paper. Mohibul Hassan Choudhury. Sorry. I mentioned the wrong name. Jannatul Ryan. Jannatul Ryan. His name is? But they mentioned the Jannatul Ryan. Okay. What's your name? Imran Hussain. কিন্তু bold করা আছে রায়হান না. Okay, Imran Hussain. Present your paper.
Downloaded to sir.
Assalamu alaikum. Greetings everyone. This is Mohammad Imran Hussain, lecturer in the Department of Textile Engineering, Northern University of Bangladesh. Today I'm here to share research insights of our project titled Banana Peel Biocoatings, a Sustainable Approach for Fire Retardancy. So before delve into the presentation, I would like to give a brief introduction of our co-authors. So first of all, Mr. G.M. Faisal, who is the leader of this project, and also head of the Department of Textile Engineering, Northern University of Bangladesh. And rest of the co-authors, except Jannatul Ryan, are all the faculty members of Department of Textile Engineering, Northern University, Bangladesh. Jannatul Ryan is our student. Okay, let's start the presentation. Today's world is concerned about the fire safety across the industrial and also residential sector due to increase the number of fire incidents. So for this, numerous studies has already been explored to address these issues. But there are some problems that we have found. First of all, elevated expense associated with advanced materials for fire retardancy. And second of all, limited utilization of the sustainable materials. And finally, the limited amount of research focused on sustainable fire retardant materials. So, to address these issues, we are introducing the banana peel, a sustainable and biodegradable and also abundant waste material worldwide, which is so inexpensive and also contains no toxicity. Okay, let's come to the material section. To conduct our research, we utilize primarily we utilize three number of materials. At first, the scoured and bleached plain woven fabric, which is 100% cotton. And secondly, banana peel. And finally, synthetic binder, polyvinyl acetate. If I go for the methodology, in here, at first we collected banana peels from tea stalls. After that, we gathered in our laboratory. By utilizing a simple blender, we blended the banana peels, and after that, we mixed with synthetic binder. In the meantime, we prepared the fabric. We cut into the fabric with our desired shape, and then we coated the mixture by handling process on cotton fabric. Then we dried the fabric with 100 degrees Celsius temperature for 45 minutes. Finally, we got our output fire retardant fabric. So, to assess the effectiveness and also to make a comparative analysis, we conducted total 6 number of tests. The first test is direct heat test, where we expose the treated and untreated fabric directly to the flame, and then 45-degree burning test. For 45-degree burning test, we place the fabric sample for both treated and untreated fabric for 45-degree angle with respect to flame, and then welding spark test. To check the spark ignition, is there any effect contains for spark ignition for both treated and untreated fabric? We did this test. And then chemical resistant testing. In here, we have used sulfuric acid drop, where 100% concentrated sulfuric acid was used. Then direct metal heat test. In here, the metal was heated around 900 degrees Celsius. Then the sample was placed on the metal surface. After that, hot nut test. In here also, the nut was heated up to 85 to 900 degrees Celsius and placed on the treated and untreated fabric. So these are the visual representation after the ignition, where B and C shows a inferior result, but better result than the treated fabric. But A, D, E, F, that's mean hot nut test, direct metal heat test, chemical resistant test, and welding spark test shows a superior results. If I elucidate it with the quantified value, then it is shown that for 45-degree burning method test, where untreated fabric required 23 seconds to burn out, the fire retardant fabric required 93 seconds to burn out. Again, we can see hot nut test. In hot nut test, it shows a significant difference, where 700% better result than the untreated fabric. After that, The chemical resistance testing. In chemical resistance testing, the sulfuric acid penetration test where drop was used, it requires 3.4 on minute to make penetration into the fabric, whereas the fire retardant fabric required 10 minutes to penetrate into the fabric. Again, in direct heat metal test, it shows a better result, almost 200 plus better results than the untreated fabric. Again, if you see the welding spark test, in here also there are notable changes or difference between the untreated fabric and fire retardant fabric is seen. Finally, the direct heat test also shows a considerable changes. This is the summary of my result, what I have already discussed. Okay. Actually, this is our primary level of research. We are continuing our research project, so there are some future scope or limitations. Like at first, we use the ratio for the synthetic binder and banana peel 1:4. So changes of the ratio can give a better result. So we are working on it in our laboratory. Again, we used the fixed GSM, which is around 160 GSM. The EPA and PPA 120 into 80. So there is some mistake, typing mistake, sorry. It should be the EPA and PPA. Another thing is the coated material, the synthetic binder, what we have used as the synthetic binder polyvinyl acetate. After drying process, it gave a harsh feeling. So we are trying to use another binder to solve this issue. So these are the future scope to work with this banana peel. So that's all about from my side. Is there any question? You can ask.
What kind of binder do you use?
Polyvinyl acetate. Acetate.
Polyvinyl acetate is a steepening agent, for fabric. It's commercially used.
So this is our initial level of work. So we are trying to substitute these things with sodium silicate and other materials. So we haven't concluded with our results. It's a continuous process. Thank you, sir.
Hello, thank you for your presentation. I also would follow my forward ask question. Is the polyvinyl acetate you used bio-based or is it fossil-based? Because in your title there are make bio-coating.
Thank you for your question. Actually, I have already mentioned that in here, although we mentioned that it is a sustainable approach, in here we have used a non-sustainable products, but we are trying to reach another conclusion with another binder. Thank you.
And my second question is, do you know the chemistry behind the banana leaf flame retardant effect? Is there some phosphorus inside, or have you make a literature research why the banana leaf is working so good?
Sorry, sir, I can't get you.
Peel, yeah, peel.
My question is there any effect on the color of your coating? Because whenever you sell a fabric, maybe black color. So whenever you coat with the banana peel, so is there any change of the color?
Yes, sir. There is also change. Something's changed. Coloring. There is change in colors, and we are trying to. As it is fire retardant fabric, obviously there should be a change of the color of it is, because we are treating with something that is not directly related to the fabric color.
but you must meet one concrete color.
Yes,
so,
sir.
So I think you also look at this matter.
We have focused on the safety purpose, but thank you for your suggestion. We will work on it. Thank you.
Okay, thank you.
Any more question, please?
Thank you. I have
Thank
one
you, everyone.
question also. So I just saw that one test that one sample is untreated. That is firefight retardancy test is 20 seconds, right? And the treated sample is 93 seconds. So seconds is just 1 minute and 30 seconds. So my question is that during any kind of accident, sometimes it takes a long time to control the fire. So what do you think? Can you use this kind of fabric as a firefighter in the firefighter suit to make the firefighter dresses?
Thank you, madam. It's a mediocre level of fire retardant materials, so we are trying to improve its performance. Thank you.
I gave you some suggestion also. You have to also taste the TG or something HRR, TMI. So that's Belu gave you the hard question also. Okay?
Thank you, madam,
so
for your suggestion.
Directly the time is not enough to answering this type of question. Okay, so thank you. So thank you. Your name is?
Mohammad Imran Hussain.
Imran Hussain.
Thank you, madam.
So
Welcome.
thank you, Imran Hussain.
Assalamu alaikum.
Wa alaikum assalam. So next one, Najmus Saqib.
Assalamu alaikum. Thank you for the golden opportunity to show our research in this international competition. My name is Najmus Saqib. I am the main author of this paper, and let me introduce my co-author. Is Uchchas Kumar Sarkar and Shobuj Mia. The content of our work is different types of polyester fabric dyeing with natural dye, enhancing performance and sustainability. For the introduction part, we all know that Bangladesh is the second largest garments manufacturing country. We expose a lot of amount of chemical in our environment. To make harm in our ecobalance and ecosystem. So environment concern is more alarming issue in here. So eco-friendly product is most priority in our garments industry to save our world for the future. And we try to explore the natural dyes properties and try to apply with polyester synthetic fiber and compare it with cotton, wool, silk and jute. But unfortunately we only compare with cotton, and next research we will try to compare polyester fabric with natural dyes with the wool, silk and jute. We try to evaluate the color fastness and physical performance and compare with ordinary fabric, and try to evaluate the importance of sustainability and the sustainability of polyester dyeing. Here is our objectives. We explored the dyeing techniques of natural dyes and try to know about characteristics of peri-eco color. Red CS, it's a naturally It's a pigment dye. We assessing the natural dyes properties and characteristics on polyester fabric and enhancing the performance after dye, and the sustainable practice gain in the garments industry about the polyester fabric and ordinary fabric for after the natural dye, and try to discuss the challenges and solution about the problems, and give some suggestion because we get some problem after natural dye, apply natural dye in polyester fabric. Here we express materials we have used during the experiment. We actually use single jersey 160 GSM in different composition for the polyester purpose. We use 100% polyester fabric which come from 75 denier, 72 filament spun polyester for the 100% polyester fabric, and we used PC fabric for 80% recycled polyester, and then we use CVC single jersey fabric for obtained 40% recycled polyester, and all the fabrics and materials we collect from the interest of meeting and interest of group. And finally, as we use natural dye in the polyester fabric, we try to collect these natural dyes from Dr. Petri Textile Auxiliary, which is called from the local markets. Its name Text Solution Service. They provide or sell these natural dyes for industrial or commercial dyeing purposes. We try to find out the commercial problem and commercial application in the natural dye in the garments manufacturing, and obtain the problem and benefit for the natural resources. For the method, as we use RFD form fabric, so we need to first of all we need to lay wash this fabric to increase the dye take-up percentage, because if we don't do the lay wash, the fabric take the dyes less amount from the bath. Before dye application, we give some enzyme and acetic acid to remove the impurity and projectile fiber at 50 degrees Celsius temperature for 10 minutes, and keep the liquor ratio 1:20. And we try to avoid the p-catenization process, but if we get better color shade and better bonding, we must use this process p-catenization. So we use RDL and catenizer for bonding, better bonding, and try to keep the pH 9 to 10. It's our main part of the work. We apply Perico Red CS on the polyester and polyester blend fabric. For this method, we first of all avoid the salt and soda, as it's a natural process. So we try to avoid the salt and soda. So it is a salt and soda free process. For this maintain, we apply the dyes on the fabric for the different types of polyester fabric in a different dye bath at 60 degrees Celsius temperature, and for the 20 minutes. And after then we treat it with non-ionic detergent and send it for cold wash to keep the pH 4.5 to 5.5 for better reaction. And finally, we use 1% non-ionic detergent for cold wash to better neutralization of different types of polyester fabric. Here some results after dyeing. We use 3 different types of polyester fabric. Here 100% recycled polyester fabric, and 80% recycled polyester, and 64 CVC fabric. The result shows that all of the color fastness to wash obtain satisfactory due to better bonding with cotton fixation of the natural dyes. So there is no issue after dyeing color fastness, we get satisfactory. And then we send it to for color fastness to light. We obtain color fastness to light around 3, which is not very good, but is commercially okay. And color fastness to wash, here also result better for all types of fabric, 100% polyester, 80% or 60-40% fabric. It's come because the polyester fabric is better bonding with after neutralization, so color fastness results not impact in our result. And finally, we discuss about main issue after dyeing is rubbing, because after rubbing the 100% recycled polyester fabric result is very poor due to the low dye affinity on polyester, because natural dyes are pigment dyes. So rubbing property and rubbing characteristics slightly poor after dyeing on 100% recycled polyester, but satisfactory in 60%, 60%, 60-40 and 80% recycled polyester. Here we discuss about color assessment after dyeing with color standard of 100% cotton. Here we can see that the color difference between the 100%, 80% and 40% recycled polyester with 100% standard cotton. Color shade slightly lighter to darker. We get the slightly darker from the 100% cotton standard, and very lighter from the 100% cotton with 100% recycled polyester fabric. Effect of color shade. We obtain that after dyeing the 100% recycled polyester fabric is 20% lighter from the standard and 15% lighter on 80% recycled polyester and 10% lighter for 60-40 CBC polyester fabric. So it's more closer to 100% cotton fabric is 60-40 CBC fabric that contains 40% polyester, and very different color obtained in 100% recycled polyester due to dye affinity in polyester fabric for the pigment dye. And color fastness, effect of color fastness property. Effect of color fastness property. Color fastness of polyester fabric on eco rates is good to excel and for all kinds of color test, washing, color fastness to washing, water and rubbing, except rubbing, because we obtain that rubbing property is not very good for polyester. It's one of the most important properties after dye of the recycled polyester fabrics is strain test before and after dye. Here we can see that the green portion of the fabric is dyed fabric. That means after natural dye applied in the polyester fabric, and the red portion is undyed fabric. We all know that the washing test is all depends on the air permeability of the fabric. Due to dyeing, the fabric compactness is increased, and strain test result will increase.
Sorry, I'm going to interrupt you. You have to finish within 1 minute, please.
Actually, 100% recycled polyester, 80% recycled polyester, and 40% recycled polyester has different types of air permeability because of the compactness of the yarn for different composition, and then strength of the fabric and difference. So it is closer to undyed fabric is 100% recycled polyester, because the polyester fabric's wear permeability higher and strength of the fabric is very high. 40% polyester fabric strength is comparatively low, because the fabric strength and wear permeability is very high. Here we get some problem after dyeing or challenges, because most of the natural dyes are contained for light shade fabric, so darker shade cannot be obtained, and we need to dye the fabric in garments form, and color variation by color shade is very high for garments to garments.
Sorry, I stop there. I have a question first to go to audience. Where you get the idea to dye the recycled polyester fiber with natural dyes?
Because in commercial production, we usually not use polyester fabric for natural dyes. So we try to obtain the main problem and characteristics, the idea, and generate this for our research work.
Do you have get any research paper or another research somewhere
No,
else?
this is my first research paper, and this is my first conference paper.
So why you think that is suitable for recycled fiber?
I researched some idea and generate it, because applying in the natural dyes in polyester fabric is more cheap and available cheap, and it's cost effectively, so I implement it.
So, okay, do you have any question, please?
Okay. You use the natural dyes, right?
Yes.
So what kind of dyes have actually this natural dye?
This is actually Perico Color Eco Red CS is purchasing from commercially.
So is it food color?
No, it is obtained from mineral.
I think you mentioned the generic name, right?
Yes, sir.
So is there any chemical structure?
No, sir. I have no idea about the chemical structure.
Trade name.
Yes.
You need to mention the generic name.
Yes.
CI disperse or CI something. Otherwise, we cannot understand how can it interact with the polyester fabric.
Okay. Okay, sir.
Hello. Here I have to add, these dyestuffs are inorganic pigments, therefore there is no chemical structure or generic name. It is a crystal structure, maybe for mixed composites. So therefore also they are quite new. Therefore is no color index number or structure available.
Yes. It's pigment dyes, but it's obtained from natural or.
How can it be pigment dye? Can you explain it?
It's maybe I searched it about dyes. It's mentioned that it's a pigment dye, natural pigment dye.
But what did you learn?
Can you answer the question? No. Okay, next one.
Okay, you have in your proposal you have said that and performance analysis. You are using dyes and dyeing also, but have you tested any dyeing performances here?
Dyeing performance means that I test it for physical and chemical test. For
This is not the exact dyeing test.
no, not dyeing test.
Have you measured any of the dyeing performances?
No. It's just physical chemical test.
So you are using a dye, right?
Yes.
You are using a dye, but you are not measuring any of the dyeing performances.
No.
So is that a, I think, some research gap, right?
Yes.
Okay.
I have a question also. Your dyeing temperature is 60 degrees Celsius, right?
Yes.
But normally we know that the polyester fabric is dyeing is done at 120 degrees Celsius with dispersed dyes. And the dyes, discharge dyes are inserted into the dye molecules. And only this, I'm a little bit confused. Only 60 degrees temperature is possible to dye polyester fabric with this pigments, colorant?
Yes. As it's a natural dye and it can be possible in 60 degree temperature, and that's why it's sustainable for it's helpful to reduce the temperature and consume the power. So
polyester itself is synthetic fibers. It's not a sustainable product as well, right?
Yes.
So it's a very confusing research also. So you have to done more work on it.
Okay, ma'am. Thank you.
Okay,
for
thank
the
you.
suggestion.
Are you familiar with glass TG?
Yes.
Polyester? You know what is the TG of polyester?
One actually not remember it right now. Around 120.
You have to go through the pigment dyeing system, yeah?
Yes.
But you usually use the exhaust process, like reactive dyes, react dyes, substantive dye. So your dyes is not a substantive dyes. It's the pigment or mineral. You mentioned all this.
Yes,
yeah?
it's a pigment.
So
natural
you have
dye.
to follow those procedure. How can we penetrate the dyes into the fiber?
As we
Okay.
use the binder before dyes, so dye take a part in the English and color penetrate in the fabric.
Okay. I think, do you have any question
Yes.
more?
Hello?
Any more question more?
Hello. My question is, in the title, I have problem. You have written different types of polyester.
Yes.
But you haven't used different types of polyester.
Different
Different types. Maybe you have used blend.
Different types of blend
but
polyester.
but it's not different types of polyester.
Different composition for polyester
Yeah,
fabric.
So not different types. Another thing is, what is the unique of your research? Because you have collected dyes from Petri or others. You have just did some comparative test. It is the common thing. So I cannot tell it is actual research.
Actually, we try to find out the commercial application of natural dye polyester fabric.
So it is recommended by the manufacturer, not yours.
But actually, sir, normally we not apply polyester and natural dye in polyester, and we try to find out the main problem and characteristics of the fabric of polyester, different types of polyester in natural dye.
So how many washes the fabric was last? How many washes? How many washes the color was on the fabric? It was on the fabric. 5 wash, 25 wash. Do you know?
Yes,
Have you tested it?
it's a 5 wash, 5-time wash.
I think it will not actually work. So I think you should consult with some text dyeing expert. This is my recommendation.
Okay, sir. Thank you for your suggestion.
So, any more question? I think no. Do you have any question more? Okay, thank you. Thank you so much.
Thank you.
Saki. Give him a clap also. So, okay, তুমি শেষ করবা? Okay, thank you so much, everyone. And I think I have prayer time, so I have to leave quickly from this room and hand over the mic to Jamie. Thank you, everyone.
Thank you. I would like to convey my heartiest gratitude to the Honorable Session Chair, Professor Dr. Sharfunnahar Arju, and Honorable Co-Chair, Professor Dr. Kanis Farhana Ma'am, for conducting the session successfully. Now we have come to the end of our today's technical session. Heartiest gratitude to all of you for your graceful presence here throughout the day. Special thanks to the researchers and paper presenters for sharing your thought-provoking ideas with us. Now we have another attractive session to attend at Butex Auditorium, and that is poster presentation. I would like to request you all to go to the Butex Auditorium to enjoy the poster presentation session. I am Tabassum Ferdows, Assistant Professor, Department of Wet Process Engineering. We'd like to announce the closing of today's technical session of 2nd International Conference on Textile Science and Engineering 2024 by thanking you all once again. Thank you all.